Okay, so last time we talked about systems of equations, right? We talked about two equations, two variables, and different ways to solve it. And the different ways we had to solve last time was substitution, elimination, and graphing. We talked about graphing being not very efficient, not super helpful, but it's a great picture of what's going on. Substitution, elimination are the way to go. It just kind of depends on the problem. So this is section 5.2, which is systems of equations with three variables. And that's what makes these problems a bit longer. Okay, so an equation with three variables. Before we had two variables, we used x and y for our two variables. If we have three variables, we're going to add in z. So our equation's in the form like ax plus by plus c times z equals some number d. So that's kind of what our three variable equation is going to look like. When you have a equation with three variables, that means that there's three different dimensions. So instead of this being a line like before, a line is a two-dimensional object. In three dimensions, that would be like a plane. So I'm not going to attempt to draw that. You do not have to graph any of this stuff, but this is a plane technically in a three-dimensional space. Okay, this the idea essentially is if x is still going up and down, nope. If x is still going horizontally and y is going vertically, z is like coming out at you, like coming up out of the paper. Okay, when you actually graph it, you don't do it quite that way, but that's the idea. Okay, so the first type of problem for these is asking, is something a solution? Just a heads up, the ordered pair for these are going to be like x, y, and the last number is z. Whereas before your ordered pair was just x comma y, now it's x comma y comma z. Okay, so one type of problem is the problem where it says show that the solution -1 to -2 is a solution to the system of equations. If I have three variables, how many equations do I have to have? Three equations, okay? So x plus 2y minus 3z equals 9. 2x minus y plus 2z equals -8. And -x plus 3y minus 4z equals 15. Okay, so if I want to show that this is a solution, I need to plug it into all of my equations here. I'm going to label my equations number 1, number 2, and number 3 so that I can kind of keep them straight. And we're going to do this kind of throughout the day today. So starting off by plugging it into equation number 1, the equation is x plus 2y minus 3z equals 9. Again, what we're plugging in is this ordered pair, and this ordered pair, x is -1, y is 2, z is -2. So let me plug this in. This would be -1 plus 2 times 2 minus 3 times -2. Does that equal 9? Sorry, let me log out. Well, never mind. So I get -1 plus 4 plus 6. Does that equal 9? Yes. So the solution works for the first equation. Let's do it with the second equation. I'm going to plug in the second equation. 2x minus y plus 2z equals -8. So 2 times -1 minus 2 plus 2 times -2. Does that equal -8? 2 times -1 is -2, minus 2. 2 times -2 is -4. And -2 and -2 and -4 is -8. So it works for the second equation. And then for the third equation, excuse me, third equation is -x plus 3y minus 4z equals 15. So -x, that would be -1 plus 3 times 2 minus 4 times -2, trying to get to 15. -1 is +1 plus 6 plus 8, -4 times -2, and 15 does equal 15. So it is a solution, and we just showed that it was a solution by plugging it into all of the equations. Okay, so let's get started solving. Okay, so the way that we solve systems with 3 equations, the goal is, your first step for every problem is get it to 2 equations with 2 variables. If you can get it to 2 equations with 2 variables, then you can just solve it like you did last time, okay? So once you can get 2 equations with 2 variables and you solve it, then you just back substitute to finish and get all the other answers. Oh, I spelled that wrong. Let's see. Substitute. Okay, so not many steps when you write it down with words, but the getting it to 2 equations with 2 variables is a little bit of work. Okay, so let's start off with the problem. And as you're writing this down, be very careful you don't write it down incorrectly, because there's nothing worse than doing all this work and then getting the wrong answer because you wrote the problem down wrong. So 5x minus 2y minus 4z equals 3. 3x plus 3y plus 2z equals -3. And -2x plus 5y plus 3z equals 3. Okay, that's the first problem we're going to solve. So what we want to do, first of all, let me label these equations. 1, 2, 3. You don't necessarily have to do this when you're working it out. I just try to make it easier for you to follow along. Okay, so our goal is to get it down to 2 equations, 2 variables. All 3 of these equations have all 3 variables. So it truly does not matter which one you pick to get rid of. You got to pick the same letter to get rid of in both of the equations though. So what we usually do is we kind of look at our x's, we kind of look at our y's, kind of look at our z's and see, does anything on its own already cancel out? So if you look at your x's, if I put the first 2 together, nothing cancels out. If I put number 2 and 3 together, nothing's going to cancel out. 1 and 3, nothing's going to cancel out, right? And if I was going to, like, just looking at the x's, trying to make the x's cancel out, if I did like the 1 and 2, I'd have to multiply them both by something, right? If I did 2 and 3, I'd have to multiply them both by something. Same thing for 1 and 3. So we can do that, but that's like the maximum amount of work to get rid of x. So let's look at the y's now. Same thing for the y's, 2, 3, and 5. Nothing's going to cancel out on its own. I can get 2 and 3 to the same number, but I have to multiply them both sides by something, so on and so forth, right? If you look at your z's, though, does anything cancel out on its own? No, but notice with equation 1 and 2, -4 and +2, all I have to do is multiply that bottom equation by 2, and then they're the same number and cancels out. Okay, so out of the 3 letters, Z is a tiny bit faster. Not much, but a little bit, but you take what you can get at this point. So we are going to get rid of Z here. You could still do it getting rid of Y or X. It's just a little bit faster if you get rid of Z. So our goal here is to eliminate Z in 2 equations, okay? So we have to get 2 new equations that do not have Z in it. Yeah.
So the first one we did, you were given the
You were told the answer and you're trying to just check and make sure it works. Here, we're trying to find the answer. Okay, so to eliminate Z, I'm going to start off by taking equation number 1 and 2, and I'm going to get rid of Z. So equation number 1 is 5x minus 2y minus 4z equals 3. And equation number 2 is 3x plus 3y plus 2z equals -3. To make the z's go away, one of them is -4, the other is +2. Which equation do we need to multiply, and what do we multiply by? We need to multiply the bottom equation by 2. The top one's negative already.
Oh.
So when I do that, let me rewrite my top equation. 5x minus 2y minus 4z equals 3. The bottom equation is now 3x times 2 is 6x. 3y times 2 is 6y. 2z times 2 is 4z. -3 times 2 is -6. And then we are going to add our equations together. 5x plus 6x is 11x. -2y and 6y is 4y. -4z and +4z, they cancel out, equals 3 and -6 is -3. Okay, so this is one of our new equations that we are going to use. Okay, so you can call this whatever you want. I'm going to call it equation number 4. You could call it equation B. You could call it equation star. You could call it whatever you want. Okay, but we're going to come back to that in a minute. So remember, our goal was to get 2 equations with 2 variables. Right now I have 1 equation with 2 variables. I need to do this whole process again. I have to pick 2 different equations starting off, but I still eliminate Z again. Okay, so you're still eliminating the same letter. But now, instead of 1 and 2, I need to pick 2 other equations. What 2 other equations do you want to pick? 2 and 3. You could pick 1 and 3. It doesn't matter. You just can't pick 1 and 2 again. So if I pick 2 and 3, equation 2 is 3x plus 3y plus 2z equals -3. And number 3 is -2x plus 5y plus 3z equals +3. Okay, I want to get rid of z. I have 2z on top, 3z on bottom. What do they both need to turn into? A 6z. One needs to be negative, the other needs to be positive. Okay, so let's multiply our top equation by -3 and the bottom equation by +2. You could do +3, -2, it doesn't matter. And our 2 new equations now are 3x times -3 is -9x. 3y times -3 is -9y. 2z times -3 is -6z. -3 times -3 is +9. The bottom equation, negative 2x times 2 is negative 4x. 5y times 2 is 10y. 3z times 2 is 6z. And 3 times 2 is 6. So now you want to add your equations together. Negative 9x and negative 4x makes negative 13x. Negative 9y and 10y is 1y. My z's undo each other. And 9 plus 6 is 15. Okay, this is our other new equation. Call it what you want. I'm gonna call it equation number 5. Call it smiley face. Call it B. Whatever you want to call it. It doesn't matter. But I did step 1 now. Step 1 is get 2 equations with 2 variables. I have 2 new equations that have 2 new variables. So my 2 new equations, so this is like equation 4 and 5. 11x plus 4y equals negative 3. And negative 13x plus y equals 15. So now I want to solve that. Once I get an answer, an x or a y, then I can just back substitute all of it to get all the answers. Okay, so at this point, you decide to set up for substitution or elimination. Pretty much all these are all elimination on this type of problem. Do you want to get rid of x's or y's? You could get rid of x. If you got rid of x, you'd have to multiply the top equation by 13 and the bottom one by 11. It's possible. But if you look over at the y's, the top one's 4y, the bottom one's just y. I can multiply just the bottom equation by negative 4 and make the y's go away. It's easier to turn 1 and 4 into both 4s than it is to turn 11 and 13 into the same number. That's the reason why we did that. It's not wrong. It's just a little bit easier. So on top, I get 11x plus 4y equals negative 3. On bottom, negative 13 times 4, 52, positive 52. Is that right? 40 and 12, yeah. And then minus 4y equals negative 60. $11x plus 52x is 63x. 4y and negative 4y undo each other. Negative 3 and negative 60. This negative 63. Solve for x, divide both sides by 63. And you get x equals negative 1. Just a heads up, on all of these problems, your answers are whole numbers and they're probably small whole numbers. So like 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, negative 4, negative 5. If you got 3 8s there, you did something wrong all the way back through. Good luck trying to find it. That's the hardest part, is trying to find your mistake. Once we have x, I need to find y and z. How am I going to find y and z? Plug it back in. You have 5 equations to choose from. Okay. If you start back at the top, equation 1, 2, and 3, and I just plug in x, can I solve for y and z there? Technically, you could by doing this whole process over again, but that's a lot of work. Instead, let's look at equation 4 or 5. If I plugged in x into one of those, isn't it a lot easier to solve for y there? Yeah. So pick one of them. Pick 4 or 5. I'm going to pick 5. And I'm going to plug in negative 1 for x. So equation number 5 is negative 13 times negative 1 plus y equals 15. So this is positive 13 plus y equals 15. So y equals 2. I have an x, I have a y, I need to find a z. How am I going to find z? Yeah, plug it back into one of the original ones. You got 3 choices. Which one looks the easiest? 2. So I am out of room. I'm gonna make a little box right here. That's where I'm gonna do number 2. So I'm gonna plug in equation number 2. It is 3 times x, which is -1, plus 3 times y, which is 2, plus 2z equals -3. So that's -3 plus 6 plus 2z equals -3. -3 and 6 is 3. When I subtract it, I get 2z equals -6. Divide by 2, and I get z equals -3. Write your answers in order pair, x, y, z. So my answer is -1 is the x value, the y value is 2, the z value is -3. And that's your answer. It's a doozy. Okay, so again, recap. You start off with 3 equations. Pick a letter to get rid of. It does not matter which letter. Sometimes one is easier than the other. So just kind of like assess and look at it, decide which one you're going to get rid of. Pick 2 equations, get rid of that letter. Pick 2 different equations, get rid of the same letter. Those 2 new equations, solve them to get one answer, and then back substitute your way back up to get all the other answers. Okay, let's do another one. The good news is I did like the hard one first. Like that's about as hard as it gets. Yeah. Yes, but it's not a lot faster. We're going to do we're starting matrices next time on Monday. It's not a ton faster with matrices. So yes. You will have three different ways to do this. And lots of times people pick this way just because it's the easiest out of all the 3 options. Least amount of time? I don't know. They all suck. That's all it comes down to. Okay, so that was like the hardest kind of problem. We did the most like multiplying equations and everything. So here's a little bit of an easier problem, okay? It's still the same idea. The first equation is x plus z equals 8. The next equation is x plus y plus 2z equals 17. And the third equation is x plus 2y plus z equals 16. This is easier because your first step says get 2 equations with 2 variables. Do I already have one of the equations with 2 variables? Yeah, I already have this first equation just has x and z. So technically, step 1 is halfway done, right? Equation 1 can count as one of my equations with 1 variable. So now I just need to get another equation that has the same variable. So what letter do I need to eliminate here? Yeah, you have to eliminate y. And again, the reason why I had picked y is because the first equation already eliminated y for me. What equations am I going to use to eliminate y? 2 and 3, because those are the only ones that have y in them. Okay, so I'm going to pick equation 2 and 3, and I'm going to eliminate y. So it's x plus y plus 2z equals 17. X plus 2y plus z equals 16. To eliminate y, the first equation has, the equation number 2, the top one has 1y, the bottom one has 2 y's. Which equation do I need to multiply by what?
The top one by -2.
You got to multiply the top equation times -2. So when I do that, I get -2x minus 2y minus 4z equals -34. The bottom equation is still x plus 2y plus z equals 16. And then when I add them together, -2x and x is negative 1x, negative 2y and positive 2y, undo each other. Negative 4z and 1z is negative 3z. And negative 34 and 16 is negative 18. Yeah. Okay, so that new equation is equation number 4. Usually at this point, we do the same thing to 2 other equations so that we can get equation number 5. But in this case, I didn't actually have to because equation 1 suffices for that. So now I'm going to take 1 and 4 and solve those, or solve with those. So equation number 1 is x plus z equals 8. Equation number 2 is negative x minus 3z equals negative 18. Which letter do you want to get rid of here? X, because it already eliminates itself. Positive x and negative x, when I add these together, those undo each other, right? Z and negative 3z is negative 2z. And 8 and negative 18 is negative 10. Does divide by negative 2. And we get z equals 5. So now to solve, I'm going to back substitute. What equation do you want to plug z into? Yeah, I'm going to put in the first one. The first equation is x plus z equals 8. So x plus 5 equals 8. So x equals 3. And now, to find y, you need to plug both of those back into an equation to solve for y. Obviously, I'm not going to pick the first equation because it doesn't have a y in it. So let me pick the second equation or the third. It doesn't matter. It's all the same. I pick the second equation. X plus y plus 2z equals 17. When I plug in x, 3 plus y plus 2 times 5 equals 17. So 2 times 5 is 10 and 10 plus 3 is 13. When I subtract 13, I get 4 as my answer. So your answer is x comma y comma z. So 3 comma 4 comma 5. Questions about that? Okay, that's the gist for today. We're going to stop there. You have a few problems like these on your homework. Again, take your time, be very careful, write it down correctly, because there really truly is nothing worse than writing the problem down wrong and doing all this work and then getting it completely wrong for that. Just a reminder, for just a second, let me stop recording.